Alright everybody, so today what we're going to do is look at vectors, how to break them down into their constituent forces, and how to combine multiple vectors together into one. So, first things first, a vector is usually drawn like this. We usually have a starting point, and we have an arrow coming out from the vector. Now, traditionally, the longer the arrow, the larger the force or whatever we're measuring is, but a lot of times we don't actually know what that is ahead of time, so we just draw an arrow. Now, when we draw these arrows, we can kind of think of them on a coordinate grid, where we have the origin of the arrow being at our origin, the 0, 0 point. Now, depending on which direction the arrow is pointing, we say the arrow has a certain sense. So, if we think about the x-axis here, this is the positive x-axis, and if we think about the y-axis here, this is the positive y-axis. So the arrow is going to point into one of these four quadrants. And what we do is we call this the sense of the arrow. So for example, the sense of the arrow that we drew originally, right here, is up and right. If we had an arrow pointing this way, it would be up and left. And of course, this would be down and left and down and right. So one of those four is going to be what's called the sense of the arrow. We have another way of looking at the orientation of the arrow, and we call this the actual direction. Now, the direction is a more specific measurement than the sense of the arrow is. So if we have an arrow that's pointing again like this, and we consider it on our Cartesian coordinate plane, we know the sense is up and to the right, but to put a direction on this, what we would actually need is this measurement here. Say that's 32 degrees, and we would say the actual direction of the arrow is 32 degrees, and it's going this way, which is counterclockwise. So it's 32 degrees counterclockwise of this line. Now we have to say what that line is. It's the x-axis, but it's also the positive x-axis. So we say it's 32 degrees counterclockwise of the positive x-axis. If we didn't put the positive in there, someone could say it was from the negative x-axis, and that's here, and 32 degrees counterclockwise would be like that, and we'd have exactly the opposite arrow. So you have to specify whether you're going from the positive or negative axis. Now, could you also say that instead of measuring from the x-axis, we measure from the positive y-axis, and instead say that this is 58 degrees from the positive y-axis? And it's true, we could. So you also could say that's 58 degrees, and we're going clockwise now, clockwise from the positive y-axis. Either one is fine, but this is what we call direction. Remember, the sense was just specifying which quadrant we're in. The direction, we're actually specifying exactly what the vector is. So let's erase this and we'll get to the next thing. All right. So once we have a vector, a lot of times what we want to do is break it down into its constituent x and y parts. So if we have this vector here, 49 degrees counterclockwise from the positive x-axis, we can redraw that as a right triangle. So this is our arrow, this is the original force, and it is 49 degrees. But that force can actually be broken down into an x part and a y part. So we actually could say that this is the x part of the force, and that this is the y part of the force. And the way we designate that is as I've done here with the subscripts for x and y. So we say the force is F, our force is x component is F sub x. So we can see those two things. Now, one thing I do want to point out here is if, say, fx was 8 and fy is 5, we cannot just say that f is 13. That's not true. All right. But the reason for this is when we have right triangles like this, the way that we find the hypotenuse is not by adding together the two legs of the triangle. We have to use the Pythagorean theorem. So our force would actually be the square root of 8 squared plus 5 squared, whatever that ends up being. So we have to remember that we cannot just add together the x and y components to get our overall vector force, that we have to use Pythagorean theorem to actually recompose it. So let's erase that and move on. Which brings us up to a trig review. So if you guys remember from before, we had talked about trig a little bit the other day, and for those of you wanting to use the like a quick way to remember we said SOHCAHTOA, and what this means is the S in so means sine, and the OH stands for the opposite side and the hypotenuse. Now we should probably draw a triangle to specify exactly what we're talking about here. So if I'm talking about this particular angle theta, for this angle, the opposite side is opposite of the angle, so this is opposite. The hypotenuse is, of course, always the side that's opposite of the right angle. And then the adjacent side is the side that's left, that is next to our angle. Now, some people might want to say, oh, well, this one is our adjacent side. We can't have the hypotenuse also be the adjacent side, so it has to be the other one that's left. It's right here. All right. So, sine is our opposite of our hypotenuse. Our cosine, that's the C, is adjacent over the hypotenuse, and TOA, our T, stands for tangent, and that's opposite over our adjacent side. So on this particular triangle, if we had a 3, 4, 5 triangle, and we wanted to find the sine of this angle right here, we would say the opposite side is 3, the hypotenuse was 5, and our sine is 0.6. Our cosine, we'd be looking at the adjacent side, which is 4, over our hypotenuse, which was 5, and we get 0.8. And our tangent, we would be looking at the opposite over the adjacent, so we'd have 3 over 4, 0.75. All right, so that's just our quick kind of trig review. If you need a little bit more trig review, you can go back to the previous video from last week, or there are about 1 million of these on YouTube that you can find, and they all will explain well, hopefully all, will explain basically the same idea. All right, so what we're going to do today, we had hinted at this a little bit earlier, but we are going to take a force and break it down into its constituent x and y parts. So let's pick a random angle, let's say 24 degrees. That was ugly. All right, 24 degrees. And let's give this force a magnitude. We need a magnitude also. So let's say this is 500 pounds. All right, so we want to break this down into its x and y parts. So this is our x part and our y part. So force x, force y. So to do this, we're going to look at it as a right triangle, and we're going to specify that this length of the triangle, the hypotenuse, is the 500 pounds. And we know this, even though normally it's written out here at the end of the triangle, because the overall force is 500 pounds. So that's the force of everything combined together. So we're going to put it right there on the hypotenuse, is 500. Now, what we can do is we're going to use this angle. So we'll say the sine of 24 equals the opposite side. Now, which side's opposite from the angle? That's Fy. So equals Fy over the hypotenuse, because remember, sine is so, which is sine is opposite over the hypotenuse. So opposite Fy, hypotenuse is 500. Now, I want to solve this for my Fy up here. So what I'm going to do is multiply both sides times 500. So I'll say 500 times the sine of 24 equals Fy. Now the sine of 24 is just some random number. We could look it up in a chart, or the easier way to do it is to use a calculator or a calculator online. I want to go ahead and just switch over to a online calculator. Now, one thing I want to make sure of here is that my degree and radian button right up here in the corner is set to degrees. And the easy way to check this is to do the sine of 360 degrees. So I'll say sine of 360 . And if that equals a number that's not 0, you're on the wrong one. So we want that to equal 0, so I'll hit the other one, we'll clear it. Notice also the degree symbol is highlighted here. That should be another tip off. So we'll say the sine of 360 equals 0. So now I know I'm in degrees. All right, so we want to leave this in degrees. So if we come back to our math here, we wanted 500 times the sine of 24. So we're going to say 500 times the sine of 24 equals 200 and let's just say 203. So we'll come back and we'll say that Fy equals 203. All right, so we've got the first one. Now we want to find Fx. So we can do this two ways. Since we know that this is 203, we could use tangent to relate the adjacent side to the opposite side, or we could just stick with cosine, which is what we're going to do for most part, and relate the adjacent side to the hypotenuse. So we will say that the cosine, and remember, cosine is adjacent over hypotenuse. The cosine of 24 degrees equals fx over 500. Again, we're trying to solve for this variable. So we're going to multiply both sides times 500. 500 times the cosine of 24 equals fx. So let's go back to our calculator. Clear this. 500 times the cosine of 24 and we get 457. So fx equals 457. So 457. All right, notice again the 457 plus 203 does not equal 500. If we wanted to add those up, we would have to do it the same way we do with the Pythagorean theorem, and we'd say the square root of 457 squared plus 203 squared is going to equal our force. And if we did the math on this, we would find out that that is, like we would expect, 500. All right, let's do one more. Sorry, erasing takes a while. All right, this time, let's have our angle be going this way. We'll say that that's 15 degrees. And we'll give it a magnitude of 100 newtons. All right. So, this is our force in the y direction. And our force in the x direction. Let's go ahead and redraw this to give ourselves a little bit more room. And we said our angle was 15 degrees. So, starting with the angle we have an opposite side that's unknown and a hypotenuse that is known. So we know if we use sine, we're going to be relating the opposite side to the hypotenuse. So we'll say the sine of 15 degrees is fx over 100. And so 100 times the sine of 15 degrees is fx. We'll go ahead, let's do that. So call it 26. And now we have the fy we want to find. Now notice this is the adjacent side to the angle. So we'll use cosine. So we'll say the cosine of 15 degrees is Fy over 100. Multiply 100 through both sides. So 100 times the cosine of 15 is Fy. We find it's 97. All right, so go ahead and write our numbers on here. This is 26, and that is 97. Now, one thing we need to be careful of, what is the sense of our arrow? It's going up, but it's going to the left. And remember, the left is going to be negative. So this 26 number, we're going to go ahead and make it negative 26. So fx negative 26, fy 97. Now, once we know how to break apart a vector, we can actually use that to add them together. It's almost counterintuitive because to add them together, our first step is going to be to break things apart. So let's do an example here and take a couple vectors and put them together and see what happens. And look at an example where we might use something like this. All right. So let's say we've got, piece of wood here. And we have screwed into the wood an eyelet. Let's imagine there's several things pulling on this eyelet. Let's say the first one is pulling with 500 pounds of force, and it's pulling (20°) counterclockwise of the positive x-axis. Let's say we have another one that's pulling with a sense of being down and to the right, and it's 30° to the counterclockwise of the negative y-axis. And we'll say it has a force of 400. So what we're going to do here is we're going to take each of these forces, the 500 and the 400, and break them down. For simplicity's sake, let's call this force A and this force B. So let's go ahead, we'll start with force A. It's composed of what we'll call force A in the x and force A in the y. So the x and y components of force A. And we'll do this just like we had before. So we'll say the sine of 20 equals the opposite side, which is force AY, over the hypotenuse, which is 500. So 500 times the sine of 20 equals force AY. So let's see what that is. $171. All right. Now we'll go ahead and look at force AX. So 500 times the cosine. Well, let's go ahead. Let's do the whole thing here. So the cosine of 20 degrees is the adjacent side, which is force AX over the hypotenuse, which is 500. So we'll multiply by 500 on both sides. 500 times the cosine of 20 equals force AX. So that equals 470. All right, now notice that FAY right here is going up. So we know this is going to be positive. And the force AX is going to the right, which is also positive. Now, let's go ahead and look at force B. So force B is composed of its constituent parts too, which we'll call force B in the y direction and force B in the x direction. Force B itself, of course, being the original 400 pounds. So we'll do the same thing we did before. We'll say that this is our angle, so our opposite side's here. So when we say the sine of 30 degrees is going to equal our opposite, force BX, over the hypotenuse, which is 400. Multiply 400 through on both sides. Go our calculator. It's 200. All right. Now we'll look at the adjacent side here. So we'll use cosine. Cosine of 30 degrees equals the adjacent, which is force BY over the hypotenuse, which is 400. Multiply it through on both sides. 400 times the cosine of 30 equals force BY. So that's 346. Now, something important to note here, we should check the sense of the arrow. So the arrow is going to the right, which means that the 200 is going to be positive, but the arrow is also going down, which means our force BY is negative. Now, if we want to find the overall result here, when we combine both of these two arrows, we have some result coming out. What we're going to do is we're going to add together, so we'll take the sum of our forces in the x direction, which was 470 and 200, so that's 670, and the sum of our forces in the y direction. So we had 171 and negative 346. So 171 and negative 346. negative 175. What that tells us is when we want to redraw this and have it only be one force, when we combine them together so that it's just one force, we're going to have a force in the x of 670 and a force in the y that goes down 175. So our resulting force is going to be this. Now, we can find the amount of this force, the magnitude. We have two sides, so we'll say, let's call this force result in the x, force result in the y, and this is our force result total. So if we want to find force result, it's going to be our square root of 670 squared plus 175 squared. Forgot the other number. Hold on. $175. So we have that. We'll go ahead and take the square root of our answer. We'll find it's 692. So this is 692. Now we also want to know what this angle is, and this is where we're going to use that inverse trig. So we say that the two numbers that we know best, where we didn't have to round anything, are right here and here. So we're going to go ahead and use those to find the angle. Now this is an opposite side from the angle, and this is an adjacent side. So we would say that the tangent, and I don't know what this angle is, so we're just going to call it theta. So the tangent of theta is the opposite over the adjacent, is 175 over 670. So we can use inverse trig and say that the inverse tangent of 175 over 670 equals theta. And again, if you have any trouble with this, go ahead back and look at the inverse trig video from last week. So let's go ahead and find that angle, 175 over 670. So 175 divided by 670 gives us the decimal, and now we want to take the inverse tangent of that. So we're going to take the inverse tangent of that fraction we just got, and it's about 15 degrees. So, all right. So that's how we decompose angles into their constituent x and y parts, and how we can put multiple angles together by finding the x and y's of each of the individual angles and then adding them together, using Pythagorean theorem to find the magnitude, and using inverse trig to find the angle.